Yeah, to further excel our understanding about PVT and specifically in this topic, we're going to discuss phase diagrams. It makes a lot of sense to start with some of the fundamentals that we find by studying the phase diagrams of pure components. We'll start with the so-called PT diagram for a pure component. So if you only have one component, let's say that's water, or it's methane, for instance, and you plot that up for different pressures and temperatures, you get a PT diagram, something similar to what we see on the screen in front of us. What's important to notice here is that we have a line in blue that we typically refer to as the vapor pressure line. The vapor pressure line, it's essentially just indicating a lot of vapor pressures for different temperatures and pressures. And the moment we hear vapor pressure, we should all think about, okay, then we're actually talking about a single component or a pure component system. For a multi-component system, which is what we actually deal with in nature and petroleum systems, we talk about saturation pressures, bubble points and dew points. But in this particular scenario where we talk about the vapor pressure line or the vapor pressure curve, we're talking about pure components. Worth noting is we have below this particular or above this particular curve we have single phase liquid, while below we have single phase gas. Two more things to note here is that in the bottom of this particular line we have the normal boiling point at pressure equal to atmospheric conditions. Good example of, okay, what temperature can that be? If this was water, that boiling point would be 100 degrees C, as we know every time we boil water in the kitchen. On the other side of the scale, we have this temperature and pressure called critical temperature and pressure, which is the pressure and temperature of which we can't really differentiate whether the state of that fluid is gas-like or liquid-like. Okay, that's kind of the definition of critical temperature and pressure. The nice thing about pure components is that we can actually plot it up in 3 dimensions. And why is that nice? Well, we in this course, what this course is about is an introduction to PVT, pressure, volume, and temperature. So we have a P here, we have a V here, and we have a T here. And that's really what all this course is about. The only thing is now we're studying this for a simple case, which is for pure components. So let's say we start with something above the vapor pressure line right here. We know above the vapor pressure line it should be single phase liquid. And we deplete this particular liquid down to the vapor pressure line. We're still in single phase region. What's in this particular PVT cell here is still green, indicating that we have something that's liquid-like. Worth mentioning is that we try to always use green for things that references liquid-like or oil-like properties, and we try to use red consistently for things that reference red or vapor-like or gas-like properties. When we reach the vapor pressure curve, it's important to take a closer look at what's happening on the other axis right here in the PV space. So we continue at this pressure. Okay, so we're still at this pressure, but the volumes, they change dramatically. Okay, and we go from something that's close to being pure liquid in this PVT cells to be something that's close to pure vapor. And if we continue to do that, we'll actually get something that is pure vapor. As we go also below the vapor pressure curve, then of course everything is 100% vapor. Okay, or gas in this case. as we talk about it. And if we continue to do, if we did the exercise we just did for a wide range of different temperatures, for instance, and we plot that in the PV space, we get some curves that look very familiar to a lot of people that's been doing, for instance, process engineering in university, etc., where you have a PV diagram that has a two-phase region, and where essentially the pressure doesn't change in that two-phase region, but the volume does. And on this side we have stuff that's single-phase gas, and on this side we have stuff that's single-phase liquid. So yeah, liquid